All right, we'll get started here. So welcome to the SDS2 to Tekla EPM Workflow webinar. My name is Michelle McCarthy, and I'm the VP of Revenue Operations here at SDS2. And today I have Jonathan Henricksen, Project Manager at Eminem Structures, Inc., and Chris Randolph, Tekla EPM Product Manager with me to help us demonstrate the workflow. So we'll start off with some introductions of Jonathan, Chris, and myself and our respective companies. Then we'll jump into the Estimodeling workflow, and finally we'll talk about a production workflow between SDS2 and Tekla EPM. So Jonathan, why don't you tell us a little bit about Eminem Structures?
All right, Eminem Structures is a structural and miscellaneous steel fabrication firm. We were founded in 1991, so we're celebrating our 30th year in business. We average about 2,500 tons of production each year, and are set up for a really nice year for 2021. We've been using SDS2 for about 15 years. We've been using Tekla EPM for the last 7, and really thriving with the integration capabilities between the two softwares.
Great, thanks so much. All right, so most of our customers online with us today probably know a little bit about SDS2, but for anyone that's new to SDS2, we were founded in 1981 by Jim Dager, who was a steel detailer looking to solve the problems he was struggling with back then with detailing and trying to be more automated. With that, we brought many industry firsts like automated steel detailing, automated connection design, CNC data exports, and the first analysis model import. In 2016, we were acquired by the Nemetschek Group, which is based in Munich, Germany, and has products that span the design, build, and manage spaces in architecture, engineering, and construction. They have 16 brands. Probably the two most of our customers would be most familiar with are Bluebeam and Risa. And as Jonathan said, they've been customers for about 15 years now. I actually showed 2004, Jonathan, was when you guys first started up with SDS2. And SDS2 and Tekla EPM have been working together for years. Actually, back when it was FabSuite before Tekla acquired them, we had a good relationship, and we continue that good relationship today because our focus is really to work together and serve our joint customers, which is steel fabricators. And we continue to make enhancements to help improve those data transfers and keep you guys productive. The Nemetschek company, just at a glance, we work projects from conception all the way through construction. As you can see, there's 16 brands across the top here, but really everything from architectural design all the way through to building management, Nemetschek has solutions for. Today, SDS2 continues to work on becoming more innovative with the software, more collaborative, and more reliable. And I think a lot of our customers saw that with our 2020 release. And our employees come to work every day with these 3 things in mind to try and build more of that into SDS2 software. We are headquartered out of Lincoln, Nebraska, and have about 67 employees here working for SDS2, along with a few international distributors. Projects range from commercial to heavy industrial to miscellaneous steel. And you'll see that across government projects, medical office buildings, nuclear, churches, strip malls, and anything else your imagination can come up with. I feel like we've seen that come through on SDS2 projects that come through our solid steel competition. One other thing I wanted to hit before we got into our webinar today is the ROI with SDS2. We recently did a survey of our customer base, and they brought back some pretty interesting details to us about how SDS2's impacted their business. Most of you have seen the ability to expand the capacity and take on more projects through your shops or through your detailing offices, or take on larger projects. Our customers also feel like they've got a competitive advantage when it comes to winning projects, which is great to see. And your customers as detailers and fabricators tend to be more satisfied with the quality and efficiency of your work. So I just wanted to share this with you guys so that you can see how SDS2 is helping bring more profitability to your bottom line. Today, our webinar is going to focus on the Estimodeling and production workflows between SDS2 and Tekla EPM. So you'll see that what we work through will work with either our detailing product or our Estimodeling product. And the Estimodeling product is really a use case for fabricators who maybe have a detailing license in-house, or maybe they're subbing out to detailers outside of their office, but they maybe want to do the Estimodeling workflow and they don't need a full detailing station for that. So you'll see the Estimodeling workflow can be facilitated by our Estimodeling product or by the detailing product. But when we get to the production workflows, you do need a detailing license to work through that workflow. So with that, we'll jump into our Estimodeling workflow and the product demonstration so you can see how this actually works start to finish between SDS2 and Tekla EPM. Just a couple slides before we get going into that, I do want you to kind of see how this works out when you're choosing to either do the Estimodeling workflow or if you're not. So detailers and fabricators who are using the traditional method are going to be using highlighters, spreadsheets, doing manual entry, maybe doing takeoffs from Bluebeam, and then manually inputting that into an MRP system. So hand entering that information. From the Estimodeling side, a fabricator that is doing Estimodeling is going to input or import a model. Once that comes into SDS2, it's really easy to find your high labor operations, find RFI situations, get a rapid material cost, and then the export to an MRP system like Tekla EPM will allow you to reduce that manual data entry. So that's kind of this line here, going to the automated MRP system. When you win the bid, then you've got a couple other advantages. Your RFIs can go out immediately. You could also negotiate some lower cost structural design alternatives. If you find something that's really high cost based on what's called out in the structural drawings, with SDS2, that connection design capability can allow you to produce alternatives that are backed up by design calculations. So you can maybe validate, hey, I can save you, my customer, some money if we do it this way. Additionally, your detailing has a head start from that model, and your material ordering has a head start because you can start doing ABMs and everything from that detailing model. So what that workflow looks like is importing a model or importing PDFs. If you import a PDF, you'll use that as a guide to trace members over on your different elevations and input columns and beams that way. From there, in SDS2, it's going to take care of the connection design automatically for you by designing realistic connections. The materials are going to get added as a part of that design, as will the cuts and copes and all the materials and welds. From here, you can identify potential issues like looking for high labor situations, which I mentioned before, which could be non-square cut ends that maybe you can actually change to square cut ends to reduce some of that labor. It could be looking for web doublers or any other inefficiencies you might see in your model. And all this can be done fairly automatically within SDS2. There's no third-party software required here. Additionally, you can use a cost estimator to see what some of those designs can have impacts on costs. Good example would just be if you have the ability to design your connections however you want to. You know, it's not something that's spec'd out. You could compare bolted clip angles and maybe shear tabs and see what the difference is in those costs. You can use the SDS2 cost estimator tool. This is found on the SDS2 toolbox page of our website, and as long as you're up to date with your maintenance or on a subscription, you can download that for free and add it into the software. Once you get that information in SDS2 the way you want it, export that out to Tekla EPM or a similar MIS or MRP product, and hopefully you win the bid. That's the end goal of all this, is to get you to get the most competitive, most accurate bid at the end of the day. So with that, now we'll jump into our demonstration of the workflow, showing modeling in SDS2 and then sending it over to Tekla EPM for managing the data and getting some of your costs. To start out an Estimodeling workflow in SDS2, the modeler can either import an IFC, a CIS2 file, or a direct Revit transfer using the SDS2 round tripping tool. If you don't have that to start with, you can overlay a PDF into SDS2 and trace over it, as I'll be doing here. So I'm going to start off by adding in my columns. And you can see these show up in the 3D as I'm modeling them in my plan view. We'll put a rotation on these two as the plan calls out for. And I've turned those to solids. Now I'm going to change my elevation to 112 foot and switch my PDF to my first floor so we can see that I can trace in my beams. I'll lock in my elevations for my beams. And I can use the infinite add tool to just click and trace, making input very fast. I just turn that off to move and then turn it back on to continue. Now I'm going to change my section size to an 18 by 55 for that location and 18 by 35s for the other two. And you can see I've got a level of beams input. I'm going to multi-select my beams and copy them up. 2 more stories. So I'm going to do a copy. In this case, I'm going to do a single copy and intersection construction line for my first point. And DXDY offset for my second point, and that'll let me go up in the Z direction 12 foot. I'll do that and confirm it and okay, and confirm one more time. So very quickly, I was able to add in 3 floors of steel there. And I'm going to clear and work in just one window view now. Turn off my depth check. So you can see one of the advantages of using SDS2 in the Estimating process is that it does place the connections on your model. So if you're a shop that does shear plate connections, this would be your defaults that you would have come in. So now that I've got this model, then my next step is going to be to search for some items that might be high cost areas in my model. So I have a status set up for this that will highlight certain items. If we take a look at that, what I'm searching for is beam web doublers, non-square cut ends, and any failed connections. Those are the kind of the starting points for me. So now that we can see, okay, I've got some cyan colored items with non-square cut ends. If we take a look at them here in an elevation, you can see there's a pretty good slope that we're probably outside of the tolerance where you could square cut those ends feasibly. So those are okay. I'm fine with that. Going to uncheck this. Let's take a look at these pink ones. Those were the web doublers. So those might be something that, okay, these are just short span. I'm going to select them, do a multi-edit, and take a look at the loading on it. So if I look at the loads, those are at 45. Let's drop those back to an auto. Let the system handle them. You can see that takes that away. So we've got a little bit more reasonable connection there for the span that it's in. So those are some things that I can address within the model to help my bid get a little bit closer and make sure we're eliminating things that could be high costs in labor and materials. The next thing I'm going to do is run our cost estimator tool. This allows me to get just kind of a quick idea of what the costs of the materials in the model are without taking it out anywhere yet. So it will bring up, once that information comes up, I can get a quick glance at it. I can see, okay, my material costs are $58,128. My bolt costs are sitting at $3,000, about $3,500, just underneath. My weld costs are around $4,000, and the whole cost there are showing just under $3,000. Now I can run this to an Excel export. I'm going to do that the next time. So we'll cancel out for now. But say maybe my shop doesn't do shear plate connections. Maybe I'm a bolted shop. So what I'm going to do is make a quick change to my setup with the auto standard connections. I'm going to change 3 things here. Most of this is wide flange, so we're going to do a wide flange beam to a wide flange beam. And going into the web perpendicular, I'm going to change that from a shear plate to a clip angle. And maybe I want it bolted. Then we're going to go from beam to columns, same thing. I'm going to go into the web perpendicular. I'm going to make that a clip angle, make it bolted. Hit OK there. And into the flange perpendicular, we'll make that one also a clip angle, bolted. Once I've done that, I'm going to reprocess this and let the system run through connection design to change everything to bolted clip angle connections where it can. So now that that's processed, you can see we still have our members that are sloping with the non-square cut ends. But if we come in here and take a look at these connections, you can see we've got bolted connections. So very quick and easy way to kind of adjust an entire model in a few seconds. We'll run that cost estimator tool one more time. Except for this time, instead of looking at here, we'll create the Excel report. And so we can see our material costs. Our bolts went up to 4,500. Holes were about 4,000. And the welds are 3,000. So we can actually see that maybe the shear plate connections might be still more economical than what we had in the first place. So it gives you a really good spot check on how you want to have those connections designed that might be most efficient for you. Now, you might make up this on labor or erecting it in the field by having it bolted. So it really comes down to your preference, but you can get a very fast comparison with SDS2 in the Estimodeling workflow. So maybe I want to change back to auto standard connections to make those shear plates again. So I'll make those same changes. Shear plate. Run it back. So we have our shear plate connections. If there's any areas that you want to pre-identify with RFIs, maybe these column tops look funny, we can add a model note. And I'll throw a comment in here. That way, if you do get awarded the project, you're ready to send off RFIs, and that'll show a note in your model so you know where those are located. Just helps keep you organized. At this point, we're ready to send this off to Tekla EPM, and so what we'll do is export an IFC file. We can do it by selection, or you can do it from our main menu. You're going to want to make sure that you export welds, bolts, and holes so that you get all the information about how you're going to fabricate this, because it is an estimate, right? So you need to have that information. So we'll hit OK and export our model. At this point, we'll allow Tekla EPM to take that in and show you their side of the workflow.
In case you haven't met, I'd like to introduce you to Tekla Powerfab. It's actually a suite of tools designed for structural steel fabricators. It's a complete steel fabrication management system. The foundation of Powerfab is Tekla EPM, which stands for Estimation and Production Management. It's a tool for estimating, for material optimization and inventory, project management, and production management. Trimble Connect is for project-based communication. You may know it as a model viewer, but it's really much more. Connect is a tool for real-time, anywhere visualization and collaboration for everyone involved in a project. Tekla EPM Go is for real-time status and paperless shop floor operations. EPM Go is a web interface, so it works from any web-capable device to update production status from the shop, erection status from the field, or to view overall production status with our new dashboard feature. All these together provide an unprecedented transparency and real-time access to the project and production information for better decision making regardless of the device. Tekla EPM and Powerfab are an open solution with compatibility across the industry. We integrate with most of the equipment and software you're going to find in any fabrication shop. Before I bring in that IFC from Michelle, let's take a satellite view of workflow possibilities for an estimate. Now, EPM is a powerful tool for the estimator. It's kind of an adjustable multi-tool that can work with you and with your workflow. Tekla EPM has an easy-to-use and intuitive process to do a traditional takeoff, where you input assembly and material data into the estimating module, apply labor codes, and output a bid. What we're going to look at is the Estimodeling workflow. It's based on inputting the data, as Michelle has demonstrated, directly into the 3D model space, rather than into the estimating interface. The more accurate you make the model, the more accurate your estimate's going to be. We could start with a stick model, so maybe an IFC from the Revit design model, and then use labor codes in EPM. But really, if you want the most accurate results, an IFC generated from the detailing software is the way to go. It's just more information. That IFC, it can include welds, holes, cope information. It's just more specific and more accurate data on the labor that's going to be required than merely relying on labor codes. Now, just so you know that I'm not blowing smoke, we have a quote from one of our clients, Adam Norman at GMF. This is from an article. I highly recommend you Google this article. It's in Informed Infrastructure magazine called Increasing Profits and Winning More Work. But Adam says, we used to bid a project every 10 days. Now we're bidding 3 projects each week. Estimodeling has not only increased the accuracy of our estimates, it's also accelerated our workflow, which allows us to bid more projects. I don't know of a better way to say that, to illustrate how doing the estimodeling process can really make your estimating more productive. Now I'm going to bring that IFC into estimating. I'll do an import. As we import the IFC, we have some setup options for the project that will affect the man hours and other job costs. We have paint systems and clean systems that can be applied, as well as other settings that will affect the final bid. Also during the import, we pretty much read everything and give you the option to map it to an EPM field. I've mapped a few items, category, sequence, also camber and copes. Several fields are automatically mapped, like grade, for instance. And during the import, EPM will ask you if you want to create a Trimble Connect project, and will ask if you want to upload the IFC. So it's pretty easy and efficient way to get that Trimble Connect project with the model created and linked to the estimate. Now we'll take a look at our estimating job. Everything you see here was just brought in from the IFC. The M designates our main material. Any connection materials like clip angles, shear plates Whatever was in the model is included as submaterial. Bolts are included. Notice in additional labor at the bottom right, the hole operations and welds required have been added. And since I mapped cambers and copes, those are also included. In labor details, we can review each item and see how labor estimates have been applied. Note again, at this point, the only manual work we've done on the Tekla EPM side is to import the IFC. By default, in this estimating workflow, EPM applies a labor code of A to all material. That assigns time for unloading, moving, loading, labor that applies to everything. And of course, that's easily customizable for your shop. The other labor here is based on what was read from the model. So punch is based on actual holes. Burn is based on the number of copes. And weld is based on the welds that we read from the model. In labor diagnostics, you can get a more detailed look at what calculations have gone into determining the man hours required for each action. Tekla EPM also includes reports to summarize details on labor, material details, and to generate detailed estimate reports for your bid. Now back in Tekla EPM, let's take a look at the model interface that's launched from the estimate screen. This opens the model in Trimble Connect Desktop, which provides a nice, accurate view of the model, including bolts, holes, and welds. What's really powerful here is the link between Tekla EPM and the model. I can select a material in the model, and in EPM, I can select from model, I can do the same thing with multiple items. And I can use that to quickly find that material, to review the labor, and verify that Tekla EPM calculations match up to what I see in the model. Likewise, I can make selections in EPM and have those assemblies or materials selected in the model. and I can isolate that selection to get a better look. Also with the model interface, I can set filters. So I could view, say, by a specific category if I just want to see columns. And I can colorize by status like category, subcategory, sequence, labor codes, production codes, etc.
All right, so now let's take a look at the production workflow, and we'll hand this over to Jonathan Henricksen to give us some information about how they're doing this in a real life situation.
Thanks, Michelle. So as we onboarded with Tekla EPM or Fab Suite and that generation, we wanted to find and we needed to find a way to better communicate what's happening. Our detailers have an incredible understanding of what's happening on any given project because of the time that's spent with a model. The model becomes a key component in generating the information that we use to populate the Tekla EPM database and be able to manage production and understand what's happening in our shop. So we've spent time evaluating and looking at the workflow to take data from SDS2 to Tekla EPM, really to streamline that flow of information through the organization, throughout all of our fabrication process. We as a company have leveraged a fair amount of technology. We've become paperless in the shop. We use Tekla EPM to understand what's happening for reporting and production and piece tracking. We also use barcoding, and having that real-time feedback information is incredibly helpful to know where we're at. A big component to having a model is that we can visualize the work. Not only does that model work as a communication tool, but it helps with error checking, routing, piece tracking, status. Michelle made the comment earlier that in days before this kind of workflow, you've got a set of plans and 15 different highlighters, and you're trying to figure out where you're at and where you're going, what's done and what's not. That's all great for the few minutes that has happened between when you color coded the plan and when you're starting to analyze it. But by the end of the day, you're looking at different information. So part of visualizing the work and streamlining this information is that we can see it more or less in real time. Another big component to this is that we really wanted to eliminate multiple data entry steps. Our workflow is based on the one time that a beam or a column or a piece of material is identified is the time that it is input into the SDS2 detailing model. We don't have to re-identify or re-input that section at any point in the process, whether it's into production control or into a requisition or purchase order, onto a barcode tag, onto a shipping ticket. It all happens because of that one input into SDS2. Beyond that, we pull XML files, KISS files, CNC files, all of that information, and those file exchanges allow the data to be transferred and supplemented. We're not recreating information, but we are adding data points to that all the time throughout the whole process. And possibly the biggest component of this is that we wanted to make all of this data accessible and simple to work with. SDS2 is a wonderful product, but it takes a highly skilled individual to be able to run it. And I want to keep my detailers focused on detailing. I don't want my detailers to have to figure out what's happening in the shop and where everything is. We've got the PM and a programmer and a logistics planner that are able to do that. And with the advent of Trimble Connect and what we can do with Tekla EPM, we can do that much more efficiently and effectively across the entire team. So now let's jump into what the workflow actually looks like. Okay, to start, when we're looking to pull information or we're releasing something for production, we start with our SDS2 model. It's nice to include everything that we possibly can in that model, for starters, slabs, footings, walls, etc., so that you have not only the actual steel information that we're going to work with, but also reference information to show kind of what the ultimate structure, what the ultimate building is going to look like, and how the steel that we're working with is going to fit into that as an entire system. We use the first component that we pull out as a data export is to do a full project export, which is done through status sharing. So we're exporting via the status share tool. We export, we've spent several iterations working through this screen to figure out what system is going to work the best. But ultimately what we're doing is we're exporting an XML file of all of the data that is to be released at that given time. Another tool that is really helpful in making this process efficient, especially because we're looking at we're going to use multiple data exports to transfer the information, is to utilize the save selection tool. So I've done this as kind of a setup to kind of get us moving along here. We create and save a selection of everything that we want to export. The selection of what we're going to export is based on what is actually to be released at that point. So we grab that selection, run our status export, and generate an XML file. Beyond the status share, we also pull an IFC model from what we're looking at in the detailing system. When we're pulling the IFC model, instead of pulling just specific to be released information, we'll pull all of the data so that we can have the same level of information that the detailers are looking at available to everybody else on our team. Including bolts, holes, and welds gives us a fairly feature-rich model that we can work with to better communicate what's happening throughout all of the processes involved. Finally, beyond those first two exports, we export individual sheet PDFs for pulling into Tekla EPM. We pull a KISS file to help with cleanup of data, and we pull all of our CNC. That way, everything that we're working with gets pushed into EPM production control to be able to be used by the rest of our team to manage all of production. Once we pull the information into Tekla EPM production control, we do a little bit of cleanup work on it, adding things like lot numbers and fab routing, shipping routing, making sure that we have CNC for all of the files that we need to work with so that we can program and plan out the work that's happening in the shop. At the same time, we pull into Trimble Connect that IFC model so that we have a visual of what the project is going to look like. As you can see, it's a very clear representation of what was in SDS2 without the SDS2 user knowledge in order to be able to see and manipulate the data. Another big component, or as we were talking about, highlighting and understanding what's happening in terms of production so that we can have this data available. EPM has a model viewer interface that allows us to identify and colorize or color code what's happening in that model based on several different factors of what that data is. So for example, we can colorize by sequence and identify clearly visually right now is in real time what the different sequencing is. I mentioned that we update lot numbers. So for example, I've lotted out this model to show, different phases of building this tower off here to the right-hand side. As data is pushed from production control into purchasing, into requisitions and purchase orders and received, we're also able to track all of this information as to where the material status is. So material location status, for example, will show us color-coded instantaneously what material has been released, what material has not been released or not been moved beyond production control. That's the items that are not linked. What's still in a requisition or hasn't been purchased yet. What's in inventory or has been purchased but maybe hasn't been received. And then different color codes for where each item or each raw material piece is at in our yard or in our stock. Two other items to highlight on this. There's this dark blue color that shows up in many of these options. That's information that is not in Tekla EPM. This is the reason why we export the entire model. It's a quick error checking way to see something that may or may not have been missed in the data export. For example, this big truss back here is showing up in that dark blue color. It's not actually in Tekla EPM. Now it's time to call a detailer and find out why not. Did something get missed in how they exported it, or was it not really ready to be released at that point in time? Using the model interface, we can also turn off different sections of this to more clearly highlight where maybe we have all of the material that we need in order to begin a production sequence. Other areas that we can highlight: approval status, to track what's been released, what's not been released, where things are at in the approval process. Finishes, what material is galvanized, what material is painted, for example. Some of this stuff is information that I quickly threw into Tekla EPM to be able to highlight what some of these quick options are. And then finally, we're able to use this, and really a big component of this is being able to identify what's actually happening in production. So items that are shown in red in this display are items that are not started yet. We haven't begun fabrication processes. The light blue color is material that's been pushed through the beam line that we have in the shop. The orange is through the next fab station. All of this material, all of this color coding is updated in real time into the Trimble Connect model and into the Tekla EPM database. So as a piece gets scanned through one fabrication station, if you simply recolorize the model, you'll see updates as to what's actually happening in real time. Finally, we can track shipping status and field status if you've got information that's coming back from the erector on the job site, to identify what has been erected and how you want to track those different processes. So some best practices in terms of how to make this workflow really function and really thrive in our organization. Number one, model integrity is critical. The data flows from the SDS2 model. XML files, IFC files, CNC files are all model based, and they need to reflect what's actually in that detailing model. The model also becomes that unifying communication tool and needs to accurately reflect work that's happening in the shop. Additional data points are added to the model-based data as supplements, not as replacements. As we're adding data like fabrication routes and piece tracking, that's information that can be pushed around into other parts of other systems in our shop, and eventually can be pushed back into SDS2. And it has to be done on the same graphical item in the model, because it's all tied together using GUIDs, and that's the way these systems all communicate with each other. Boneyards of storing material off to the side are really not a helpful communication tool. The model needs to be accurate, clean, and everything needs to be modeled in position for where it's actually going to be used in the structure. Otherwise, it's just kind of ancillary information that a PM or a fabricator or a guy in the shop doesn't understand what he's working with, and we end up calling or pulling a detailer in to understand what that component is going to be used for. We use sequencing very heavily within the detailing model. Those objects that show up in that dark blue color in the Trimble Connect model can be kind of a pain. They're hard to see through and hard to see some of the stuff that's around it. Joists, for example, are a really common one that we fight against. So put the joists or put the walls, put those items into a sequence that's not really going to be used. A big number, 20, 25, if you're talking about a fairly small project like the sample model that we're working with. So that in Trimble Connect, we can toggle those sequences off, make them disappear, similar to what we can do with display options in the SDS2 model, and you can get real clearly into the information that you want to be working with. And then be creative. There's always a different way. There's always at least 3 ways to model something in SDS2. Being creative about what you're modeling can support the entire team, not necessarily what's just going to create the fastest solution for you as a detailer. Take the time to get the model correct and accurate and clean as to what we want everything to look like. Future possibilities that we can use this data for: Estimodeling, like Chris and Michelle have already talked about today. Having a model that you can pull in and tie data into the estimate and be able to reference back and forth between Trimble Connect and the estimating data is incredibly helpful. There is an ability right now that we can pull that XML file out of SDS2, work within an EPM, and then push it back into SDS2. When there are changes that come in and you have to make a drawing revision, it's really nice for the detailer to understand where things are at in production. We're also starting to get into the idea of you working with SDS2 load planning. Again, we're working with a 3-dimensional model for a project manager and a programmer. Now we can start with load planning, actually drop the material onto a truck and create better economy in how we're going to plan our production workflow. The final piece that we're working towards is being able to share the status and all of that production status information we can share with the outside world, the people that are not a part of our internal team. We can pass this Trimble Connect information to an erector, to a general contractor, to other trades on the job site, so that they can better understand where we're at, what we're doing, where we're going, and what some of this stuff looks like.
Thank you, Jonathan, for your presentation and sharing with us how you guys use Trimble Connect, Tekla EPM, and SDS2 to manage your production workflow. From here, we'll just go ahead and take it to the live Q&A. So we'll start off while some questions are rolling in here with one of the polls. And let's see here. Are you currently using an Estimodeling workflow as part of your estimating process? So if you want to take a second and answer that question, we can kind of see what the group that's with us today is doing. And in the meantime, I'm going to look at some of the questions here. The first question, Roddy Carl sent in a question earlier in the demo about what formats are available to export weld data, hole count, copes, etc. to FabTrol. We're going to have support reach out to you to answer this specifically for you, Roddy, so just keep an eye out for an email. But I did also check with James, who's worked very closely with FabTrol in the past, and he thought the XSR, which is the FabTrol export out of SDS2, might get you the closest to what you want, but I would speak specifically with the support team to get a more detailed answer than that. So while we're going further into that, maybe we can see the results of the poll. So most of you guys are not doing an Estimodeling workflow right now, but a nice little 13% of you guys are leveraging the tools you guys already have in-house. We'll move on to the next poll, and I'm going to read off the next question here. This one's going to be one for you, Chris. How does Tekla EPM estimate labor required for fitting?
All right, I have to find my unmute button there. Yeah, with estimating, all the labor is easily customizable. You have control over anything that you want to include in your estimates. So you can set that however you need to. So it's just like any other labor, you can control that in the setup.
All right, thank you, Chris. And I hope all you guys are voting here on what MIS software you're currently using: Strumis, Tekla EPM, FabTrol, EJE, or other. If you're using spreadsheets, just put in other. While everyone's voting here, I'll move on to the next question, which is, in SDS2, the XML export, do we have any setups to exclude the bolts? And if you're talking about the data transfer, when you do the full export and you're exporting all the data, that's going to include your CNC files. It's also going to generate an IFC as a part of this XML file, along with any statuses you have set on the model. In that IFC options, you have options to either include or exclude holes, bolts, and welds, or generate an EM11, which is a version of an IFC file. So, long way to get to yes, you can. Next question, is there any data that can be pulled from SDS2 that can be used to estimate actual detailing time to help our estimators better evaluate our bids? That is a good question. That's probably a little bit over my head. I know, Jonathan, you're not necessarily doing Estimodeling, but from a user standpoint, is there anything you can chime in on that?
It's not something that we're doing right now. Like you said, we're not doing any Estimodeling with it. But I believe that there are some setups. There's some, you could use some labor codes or labor additions in EPM, in the estimating module of EPM, to actually help track and kind of calculate detailing labor in addition, or create it as a labor category that's in there so that it can be analyzed, and you could kind of auto populate that. It would take some customization and setup in the background of EPM to pull it off. I don't know that there's anything else that could be pulled from SDS2 to better predict what detailing is. It's a problem that we've talked about. We haven't dug far enough into it to create a solution yet at this point.
Okay, I'm going to do a little bit digging here with our R&D team and our support team and get an answer, and I'll probably just email you back directly, Brian, on that specific question. Why don't we go ahead and close out the poll here? So you can see, of the group we've got on today with us, the majority of you guys are using Tekla EPM, some Strumis users, FabTrol, and EJE, and a good group of other users using other methods besides the 4 we have listed here. So thank you for providing those answers. I'm going to jump down to this next question, and we have one more poll that we'll throw up here. And this is just kind of a general question about the state of the industry today. As fabricators or detailers, what are some of the biggest problems that or challenges you're experiencing at this moment in time? So whether that's keeping steady work, your steel prices and availability, compatibility, or quality of drawings. I know that doesn't encompass everything. We all have lots of problems, but if you can pick one of those 4, just kind of let us know where you're sitting today at your outlook in the world. So while you have a second to answer that, we'll go to the next question, which is, can we estimate how many hours will take us to finish a job based on member properties, where we keep the member status 3D done, 2D done? So if you want to estimate how long it'll take you to complete a job, there's probably some additional detail work you could do with status and maybe custom properties, but I feel like this actually is similar to the question we had just before, where you can do some things in Tekla EPM, but I think there's some custom property items that could go into this as well. I'm sorry, that's not a great answer, but I'll probably, Catalin, I'll probably answer you also via email, just like I am with Brian, after I have a chance to do a little bit more research on this topic. So the next question in here is, once an Estimodel is created and then sent to the detailing model, can an XML be created and then sent out to Revit? I almost have another question for you, Justin, on this. Are you trying to send it back to the original Revit model or just create a Revit model from it? But once you create a model in SDS2, yes, you can export an XML with the SDS2 Connect round tripping tool that would take it into Revit and generate that model. So the answer is yes. Detailed question or detailed answer would be is if you're trying to connect up to an original model or just generate a new one. But either way, yes, you can do that. You could do an XML, which is the direct API transfer, or you could send an IFC as well. So we'll go ahead and close out this poll. And you can see it's fairly well spread, kind of across the board. But yeah, steel prices and availability I know has been a big challenge recently. Especially, I think I was talking with Jonathan about this, the fact that joist and deck is out so far, and that's impacting some of the design factors on projects right now to try and get around that availability so you don't slow down fast track projects. Do you have anything to add to that, Jonathan?
The concept of a fast track project is more or less gone in today's world, but yeah, prices and availability are insane. We just saw another tubing increase yesterday. Tubing has increased like it's up 1,250 a ton since August,
Wow.
which is just an insane number, seeing as how it was less than 800 a ton when we were in August. So it's more than doubled at this point. Yeah, that's definitely one of the biggest concerns out there in the market today.
And it doesn't seem like solving that's something we really have control of, other than trying to just be as efficient as we can with design, efficient as we can with fabricating to try and offset that in other places. But it's just kind of the reality we're stuck in right now, I think.
Yeah, pretty much the reality of today, but being, I mentioned in the presentation, be creative. We do a fair amount of design build work, so we like to partner early, and whether it's design build or it's design assist, something that we can kind of bring to the table to try to get out in front of the availability concern. Yes, the deliveries are going to be likely into 2022 at this point, but work with the design team, work with the contractor to try to create something that's more efficient, that can meet what the schedule and the market are doing, to be more efficient throughout the whole process.
Great, thank you. And it looks like the questions have kind of come to a stop here, and we're at the end of our time box anyways. So I want to thank you, Jonathan, and you, Chris, for joining us today and helping share with our customer base how Tekla EPM works, how you guys are leveraging it as a fabricator to make it work for you. So thank you all very much. And with that, we will go ahead and end the webinar. For anyone that wants to take a look at this later, it will be posted on our website as well as on our YouTube channel. Thanks.